Hi, welcome to Building SaaS with Python and Django. My name is Matt Lehman, and on this stream we work on Django apps. We put them online and make them work for other people, doing what apps do, things making websites basically. We're going to continue on actually we're going to finish off some work maybe from last time. So last stream I moved my app entirely from Heroku to DigitalOcean. And in the process, we converted a database from using PostgreSQL to using SQLite. And so I'm happy with the result of that. The app is running. I've been interacting with it. I'm actually the primary user of this app, but it is open for others. But it's been doing its thing. So it is something that I want to finish off, though, is the optimization, the configuration of the SQLite database. So I've done a bunch of research on SQLite recently and found some probably 6 or 7 optimizations that are really worth checking out and investing in. Hey, Varish, welcome. This is a continuation of some of the stuff. So this is a long series. So if you want to check out from the very beginning of this project all the way back, I've got a playlist that has every video, every line of code. It's all documented there. So you're welcome to get on that. So we're going to get into the project this evening and go through some particular SQLite configuration stuff to optimize. John, welcome. Thanks for. I did actually have a very lovely Christmas as well. I hope you did too. I did have a lovely Christmas. Thank you for that comment. So let's take a look at a very succinct X post that kind of wraps up all the stuff that I wanted to cover. And as I was doing research on SQLite and configuration, this person, Nikita, really captured largely everything that I was finding was kind of condensed into one thing. So it's a little weird maybe to be coming to this like a long X post, but it's got some good data in there. And what I'd like to do is like go over each pragma and talk a little bit about it, because some of these pragma, if you're not aware and if you don't know much about SQLite, Varish, this is actually going to be for the JourneyInbox app, not the School Desk app. Although we could do the same optimization for School Desk, but if you go show it once, this is the one I commit to showing all the code live, and I might just go do it for the School Desk app. But it'll be the same concept because School Desk has a SQLite database as well. So we have this configuration stuff that comes from SQLite, and SQLite calls them pragmas. And pragmas are essentially these different settings that you can add to your database. Some of them are persisted with the database, and if you've never used SQLite before, it's really literally just a file by the time you're done. So it is data that is persisted in a file in a binary format somewhere. Some of these pragmas are actually, I think, referred to as pure per connection. So when the app opens up the file, it is at that moment the connection that's connecting to the database through the open file handle, basically, how it wants to behave. In fact, I think this is one of them. So what I'd like to do is get the documentation up and show you side by side. Varish, that is a good comment there. I actually do have separate playlists per product. So there's a master, a main feed of every video that I've done, every stream. But you can also filter down. So if you're just interested in JourneyInbox streams, you can go check those out. If you want to just check out the School Desk ones, you can do that too. And then I've got my older projects, the ones that I shut down a while ago. So that should be pretty carved up so that you can get the right playlist that you want. A little bit more work on my part, but I think it's worth it to kind of let people see that stuff. So let's do this. Let's go to SQLite documentation. And SQLite is pretty extensively documented, which is great. And find, well, thankfully Google is able to do better than I can. We want to find the pragmas section. So there's a pragmas somewhere in here. And yeah, here we go. There's a bunch of cool stuff that's maybe worth highlighting about SQLite documentation along the way. One of these things is actually, I first encountered this, and I'm sure you can still find it today. So if you go to, where am I going? JSON.org. So this is the specification for what it means to be valid JSON, JavaScript object notation. And you might notice something very similar between these two. They both use something called railroad diagrams. And these railroad diagrams are a really interesting way to describe a format and what's allowed, and kind of break it down. So if you have a schema over here, it gives you a visual way to look at what is permitted in a particular format. In this case, JavaScript objects, and in the case over here, what's allowed as like database statements that you can execute. So like if we take a simple one here, like you can see that a JavaScript a JSON object can allow an array with an arbitrary amount of white space, and you can kind of like loop around. So the way you do follow this is like you start over here, you have to start with this character. You can go either one of these railroad paths. So you can come down to the value. The value, we'll talk about that in a second. Well, it's right below. And you can have one of those, and you loop around. If you want a second one, you can put a comma there, and you can have multiple values. Or you can have some sort of white space if you just wanted to have like an empty list, an empty array. And then a value looks like one of these, where it takes any one of these particular options. It can be a string, number, object, array, blah, blah, blah. Okay, I didn't really come here to talk about JSON, though. I just want to give you a quick example of what a railroad diagram was, so that we can see what it looks like to do a pragma in SQLite. So SQLite tries to explain all of the commands you can use and then how you would use them. So here we've got a pragma where you can optionally include a specific schema name. We're going to have a pragma name, and then we will be setting values. So it's going to look like pragma, and then the pragma name, and then we'll use the equal sign, and then we'll terminate, which all termination SQL statements is a semicolon. So that part is left off, curiously, but maybe they don't consider that a statement itself. So we've got our list here, and this is maybe a good time to like scan back and forth between our documentation and what's listed here. The first one is one that I already set, and I've already talked about it on other streams, but I'm happy to repeat it. SQLite is a database that's been around for a very long time, more than 20 years, I'm pretty sure, and they are very committed to backwards compatibility. And that commitment to backwards compatibility is so extreme that it comes at the cost of certain optimizations. So at some point in its development history, SQLite has figured out we have a better way of writing data to the database that is more efficient. But because we're so committed to that backwards format, we're not going to change the defaults. So if you want to get this better behavior, you need to basically opt into the better behavior. And that's actually why we're doing a bunch of these settings. A bunch of these things are good fits for web applications, and we want to take advantage of them. So the first one, and the biggest boost you can make if you're working with SQLite, and maybe even some of your popular web frameworks do this automatically, is set this journal mode. And the journal mode is being set to this value of WAL, which stands for the write ahead log. So essentially it is keeps the main database, and as the data is writing, it's in a separate file, and periodically that WAL file is folded into the main database in an interesting way. But by having this WAL file, writers can like append to the end and not disrupt the main database. It's a little bit more complicated. If you want to go read the details, there's tons of actually good documentation in the SQLite site to explain the WAL file and all of that. But let's go take a peek and see what it says about persistence or not. So we have a full list of pragmas that are presented here. We're going to look at a handful of them, and let's go read the notes on each of them so that we grow our understanding of what SQLite is. It's a cool product. I just did an entire course on it. I will have no problem dropping the name of the course that I took. It was really good. It's called High Performance SQLite, and it's from a gentleman named Aaron Francis, and definitely worth checking out. It is a paid course. There's a little bit of I think there's a little bit of free material, but if you want to learn like the ins and outs of SQLite far more than I'm going to demonstrate here, this is a great course that is worth your time. It is sponsored by Torso, but Aaron is quick to point out that nothing in this course was specific to Torso. It was just saying like periodically they say like some of these things are easy to do with Torso, and so but the content is very, very well done. There he is right there. And he does a good job explaining all the cool features of SQLite. So that's just one plug for that. It's something you want to go check out if you're trying to learn more about the specifics of how to use SQLite in its raw format. So we've got here this pragma information on journal mode. And you can see these different options here. The first one, delete, is the default. So if you do nothing and you start a SQLite database, it will be a journal mode of delete. And we can go check our configuration. So I've got a local database here. It's this file right here. There's already signs that it's using wall mode, but we'll take a look at it anyway. So we want to do, we're going to start the SQLite REPL basically on that particular file. And from here, you can start issuing commands. In fact, let me clear that so I can get a better view here. So we're up here, we're going to say pragma. And if you want to query what is the current value, you just put in the name, so journal mode, and you finish it with a semicolon, and it basically says, okay, you actually are interested in the value, so we'll tell you. So our current setting is wall mode, and explains the different forms here. So what this is about, it's for what is the journaling mode, or in other words, how is it going to write data to the database, and here are the different values that you can care about. And then you get down here, it says the one that I think is the most pertinent to web applications is the wall mode. It uses the write-ahead log, as we've already discussed, instead of a rollback journal. And the wall journal is persistent. So if the database has gone down and stuff hasn't been written out, which actually we can see. So these other files are indicative of there's some work that the database did not get to do, and it left around this wall file, so that eventually these will be persisted. But because I'm in a development machine, the process that is actually doing that is stopped. I'm stopping it frequently. So eventually when we start up the dev server again, it will like see, oh, there's a wall file that already exists. Let me see that there's work to do. And given enough input, it will start to flush it out, and then eventually it will delete the wall file. But you kind of want to think of these things as a unit of, like, you don't want to necessarily delete any of those. Although in this case, look at the size of that wall file. So it left the wall file present, but there are 0 bytes in it. So perhaps what would happen was the data was flushed out, and then we ended, and rather than deleting the wall file, because we stopped using SQLite with our current dev setup, it just left the file around with 0 bytes in there. So I think there's no data that still needs to be flushed to the actual database. But anyway, we're over here, and this says the wall. Okay, this is important, and this is something I want to look through these configurations. The wall journaling mode is persistent. So you set this once, and you don't have to do it again. But here's where Django comes into play. When we look at Django, where we've set this, we go down to the databases section. And actually, now that we're done with the migration, we can get rid of that. It's nice. Did we already get rid of the DJ data? Yeah, okay, let's get rid of that too. So that's cool. Cool little cleanup that we got there. So this is one of the things that is, I'm not sure how to do yet. We're going to learn together. Is this pragma setting. Notice that it says it's an init command. So the way this is going to work is when Django starts up, it's going to issue these commands to the database. So we're going to basically get a long string here, which is where we'll put our various pragma statements. So essentially, we're going to set the wall mode every time we come in. But it's kind of it doesn't matter. It doesn't if you try and set it again, like if I went over here and said pragma journal mode equals wall and did that, that is not causing, to my knowledge, is not causing the database to do any extra work. So it's, in other words, another way to say this is it should be an idempotent configuration thing where it's safe to set multiple times without any problem. So the implication there is that what we're doing with Django, we're going to set some of these things multiple times, and we're not going to be able to really differentiate between which ones are the permanent ones and which ones are the like temporary per connection ones. That will only be discoverable by reading the documentation, but we're going to set them every time anyway, so it doesn't really matter. So and then it's just repeating itself, or being more specific about what persistence means. After being set, stays in effect across multiple database connections and after closing and reopening the database. A database in wall journaling mode can only be accessed by SQL version blah blah blah. So look how long this feature has been in the database since 2010. So you just weren't, like I said, it's just set to default or set to delete as the default mode, and that's just the way it is. So we got to set that one. That one's done, and I set that one partly because it was so important for the configuration that I didn't want to leave that one out, not knowing how much effect the other optimizations would have. So let's keep looking what we've got here. Busy timeout. All right, so now we're going to get to a point where I think busy timeout is per connection. Actually, let's take a look at it. Let's see if we can get an understanding of what this is. And notice, sorry, I'm jumping around a lot. Apologies. This says busy timeout 5,000. Okay, so file that away in your brain. That number is milliseconds. So what is the busy timeout? Explain it well here. Not really. Okay, so there is a downside to SQLite, and that downside, or a primary downside, is that there can only be one writer to the database at a time, and the wall system makes this a little bit more bearable because it speeds up performance so much by writing to the end of this that L. Remember that L in wall stands for log, so it's writing stuff to like the tail of the file, so it's as quick as it can be. And the default mode was like copying chunks of data out to a temporary place, updating it, and then copying it back in, which is pretty slow. So the impact of having a single writer is diminished by being in wall mode. However, it doesn't mean that it's impossible for two people to want to write to the database file at the same time. And that's where there's a problem. So the default behavior in SQLite is if you have the database, like I think this value, in fact, let's go query it. Let's go find out what it is. I'm pretty sure I know what it is, but let's see. So pragma busy timeout, what is this value? So it's set to 0, which effectively means if you and I are trying to write to the database at the same moment, and mine gets there just before yours, what happens is SQLite issues an exclusive lock and grants it to me. And if that busy timeout is 0 and there's an exclusive lock happening, your request to write to the database is going to come out right after that, and SQLite's going to say, no, you cannot write to the database. Do not pass go, do not collect $200. It's just going to be rejected. And that will show up as an exception in your Django code. I can't remember what the exact code is, or the exact exception is, but it would come back and the write just wouldn't even be permitted. Okay, but it's only going to take me, let's say, I don't know the numbers, but let's say it takes 10 milliseconds to do the write. That could be totally off. Don't quote me on the performance of how fast SQLite can do writes, but it takes me 10 milliseconds. What if your write just waited? You said like, all right, I can't go right now, but if I just wait a little bit and am checking periodically, and I check at 11 milliseconds, so suddenly I'm going to find, oh, I can write. So this is what the busy timeout does. Busy timeout says you can set the busy timeout such that, so if we would do this, and I don't think this session or this configuration pragma is persistent, but let's just show it. So now we've got this value and we've set it to 5,000. So essentially we're saying that the next writer that's in queue basically, or is lining up behind, has 5,000 milliseconds in order to acquire the write lock before it gets that initial the rejection message that I was talking about, that error would eventually, that once that timeout happens, you'd get that error message back. So on a web application where a lot of the stuff we're doing is reading, there is, of course, some writing, but if we add a timeout here, we can greatly reduce the contention, especially if as the website starts to get more traffic and there's more writes to the database. We want to reduce that as much as possible. And this would add basically some amount of buffer where you're probably okay if the options are error and it doesn't write at all, or wait for 15 milliseconds and it writes. I think we would all agree that waiting for 15 milliseconds is a totally acceptable trade-off. So this is the thing that we want to be able to add. We need to add that configuration pragma to our database setup. So that's what what's his name? Nikita is suggesting here, and here's the actual error that you get if you did not have the setting. And you can see what it's kind of, I just kind of conveyed exactly what Nikita wrote here. So I think what I want to do, this is the part that I'm trying to figure out how do I want to show this. I think what I want to do is set this init command and set it with, whoa, come on now. Set it with a docstring style. Because if I just set a single string, I mean, I guess I could, but I don't know. So here's what I'm hoping will work just fine. This is the thing that we're going to test. So I'm going to set it like this, and it's going to send a little bit of extra white space to SQLite, but I think that's okay. So we're going to set pragma journal mode, and then we're going to do busy timeout, and we're going to set it to 5,000. I think that'll work. Now, here's the challenge. If this is per connection, this is going to be a challenging thing to validate. In fact, I don't, off the top of my head, know how to validate this. I think what we would have to do is find the actual database connection that Django is using. When Django starts up, at some point the engine is going to write. We could go look at the engine. In fact, let's go take a peek. Let's see. Let's just find out. I think if you've been watching the stream long enough, you know that I'm not afraid to like jump in and take a look at some code that I've never seen before. So let's do that. Let's go explore a little bit. Let's take a look at DB backend SQLite 3 and see if we can find some evidence of the connection. So let's open up NeoVim here, and we're going to go to DB backends SQLite 3. There's a bunch of stuff in this thing, so no clue what we're going to find. And then I'm going to look for connection. So what is this thing? This is the database wrapper. Don't know what that is or how that's used. Get new connection. Oh, look at that. Oh, cool. I don't even have to turn one of these on. Well, this is good to explore. Actually, let's check if there's any other pragmas that are hiding in here. And I'm going to use a case insensitive search by searching for here. Okay. Sorry, just going to scan through this quickly. You know what? Actually, it's better this. Let's do. We're going to just search for pragma within DB backend. Nope. What is it? Django. Oh, shoot. Not what I wanted. Hold on. We're searching for pragma. We want to look in Django DB backends SQLite 3. Okay, and let's give this more space so we can see what we got. All right, there are, what was that, 28 rows? Yep. And there's a schema version put in there. That's interesting. So it looks like Django uses the schema version. That's like a Well, I don't know. I might be off on that. So let me not make up stuff that I have a feeling I know what it is. But you can see that there's this foreign keys, and actually that was going to be one of the ones that we were to turn on. Foreign keys. So again, backwards compatibility. Because of historical reasons, foreign keys were turned off by default. And what that meant was you could create a foreign key column, which in Django is just going to be an integer. If you didn't have this foreign keys pragma turned on, if you look at Django and you do a Django model, there's behavior that happens when you delete, right? Or when you are allowing null foreign keys or not. And a lot of that stuff was actually supposed to be enforced at a database level. So let's say you have a database table and you want the foreign key to some other record to be unique. In other words, there can't be two records in your table that reference a different record in a different table. If foreign keys were set to false, then SQLite is not going to complain. It would say, oh, you want foreign key to be 42 and another row to also have foreign key be 42, and you want them to be unique. Whatever, I don't care. And that's because foreign keys is defaulting to false. So we don't actually have to update that because it looks like it's already been set in the backend itself, because foreign keys are really important to Django. So I'm glad that that one is already present. I don't know why they're turning it off for certain modes. I'm sure you could go learn about that by studying the code. Everything I see through here seems to be foreign key related. Here's a table info. So there's like some commands that are maybe probing for some information about tables and indexes. That's what this index list is. These are functions basically. So there's nothing there. Okay, that's encouraging to know what is allowed versus, or what is used versus not used from Django's perspective, which tells me that there's not much. In fact, there's probably an opportunity. There's been a bit of a renaissance with like Ruby on Rails really leaning into SQLite for a default configuration. And there's probably a bunch of learning stuff that could happen here that could fold back into Django upstream as a cool thing to add. So we wouldn't have to do a bunch of this stuff. Like, why, for example, does Django not set journal mode to wall? Like, that's silly. So anyway, we're going to operate on the only one that we're missing from Nikita's post is, or that we don't need to do, is foreign keys. Everything else need to add. So let's move to the next one. So we've got synchronous is equal to normal, and it says SQLite will sync less frequently and be more performant. Still safe to use because of the enabled wall mode. What the heck does that mean? I don't know. Or I think I do know, but I forgot. I knew at one point. Synchronous. Okay. So we want to, so looks like with synchronous off, what is it right now? There's a good question. Pragma synchronous set to 1. Okay, so it's set to normal. So query or change the setting of synchronous flag. The first query form will return the synchronous setting. So that's okay. So this is what we just did. I guess I could have done sync schema. Maybe the ones that are part of SQLite itself are under this like schema namespace. So if we did synchronous this way, no, it didn't like that. Did I spell it wrong? I spell that word wrong constantly. Maybe it's just implied for the top level stuff. I don't know. Not a pro at SQLite, but I am knowledgeable on it. Second form changes the setting. That's what we want. Okay, so when synchronous, let's look at it what it is currently and see what the behavior is. There's actually a bunch of stuff. So we want to switch to, what did they say? We want to, we want it to be normal. Why is it normal? Maybe Django set this one. Because I don't know, what would a new database be set to? Well, let's read up on it anyway. And let's query over here for normal, because maybe there's a different way the pragma is being set. So under Django DB backend SQLite 3, is normal ever coming up here? Nope. Normalize. I don't know. I don't know why that's coming up that way. Okay. When synchronous mode is normal, SQLite will sync at the most critical moments, but less often than in full mode. Okay. There's a very small, though non-zero chance that a power failure at just the wrong time could corrupt the database on the older file system, but wall mode is safe from this corruption. Okay. John, where are you seeing that? You said there's a note there? Where are you seeing that note? I'll also put down here. I see if that's what you're talking about. Wall mode is always consistent if synchronous equals normal, but wall mode does lose durability. Okay, transaction committed in wall mode might roll back on power loss. Transactions are durable. All right, SQLite tries very, very hard to preserve data. I think this system gets used in like boats, like U.S. Navy boats. So they're very, very serious about not losing information, because that's a combat scenario, and they don't want systems crashing for obvious reasons. Synchronous normal is a good choice for most applications running in wall mode. Wall mode is synchronized before each checkpoint. Wall file header is synchronized. Full. Okay. What I don't understand is, okay, here let's ask, I've got Grok because I'm now doing a Twitter or an X membership thing. Let's ask Grok. In SQLite, what is the synchronous, oh my word, synchronous option pragma set to by default? Set to full. So something somewhere in my data, I don't think I set this manually. So this is surprising to me. Let's take a look at higher than SQLite. Maybe it's somewhere else. Maybe normal shows up in more than one thing. I don't know. I don't know what it is. I'm going to just add it. I don't think it's going to harm anything if I have it here. So we will do another pragma, and we will set, spell it right, synchronous equal to normal. Okay, pragma, synchronous. And the observant among you might know, like, wait, sometimes he's doing capitalization versus sometimes he's doing lowercase. SQLite doesn't care. So that's good. Okay. Normal is also just an alias for a number, which we saw in the documentation. It's just an alias for 1. All right, that one's done. And now we know a little bit more about it. Check out cache size. So pragma, this might be I don't know, this might be a big one for me, I'm not sure. Set to 2000 already. Where are all these settings coming from? All right. Let's ask Grok again. What is the default value for pragma cache size. Minus 2000. I'm wondering if it's hallucinating, like if it's just like reading the stuff. Because I didn't set this value. So where did it get 2000 from? Did Django set that? Again, I'm getting like, it's hard to see what's set versus not set versus in these things. Is there a 2000 anywhere? Oh, there are. Oh, look at this comment. It's telling me something we should go check out. This function is limited by this. Since Python 3's... Oh, that's max column. Ah, dang. Okay. It's still an interesting thing to observe, though. Yeah, John, it's either... So this is where I'm getting confused. It's like, it's either Django or... But the thing that the signal to me that is interesting is Python. Like, what is... Because... what am I trying to say? Their SQLite comes as built in with Python, and it could be that that Python itself is setting some of these pragmas, and maybe really you can't find pragma anywhere on the SQLite page. That's crazy. Well, interesting. What if we search for synchronous? No. What? Busy? Come on. All right, this is the interface. Maybe there's like, what if we do a search for, what are we searching? One of the things we thought was not, well, that one was set, or was not set. What is one we just said synchronous, right? Is that going to show up somewhere? It's going to show up in a bunch of different ways. Okay. Or let's try Grok again. So maybe Grok knows. In my Django generated DB, the synchronous pragma was already set to normal, even though you said the default is full. Do you know where that setting came from? Can't find it in the Django source code. Middleware? I mean, something could have, I suppose. Maybe like, oh. I'm on old code. Like this init command, because that was one of the things I hit last week, is right, like if I search for init command, I think I'm gonna get nothing or very little. It didn't work on SQLite. And it was because when I tried to deploy it said like, nope, this isn't supported. And then we had to upgrade from 5.0 to 5.1. So I'm on an old, wow, so old that I've got a Vim swap file in there. That's interesting. Get out of here. Django shortcuts. Goodbye. Let's pull from main and let's do that search again. We're behind. So this could explain, maybe there's been some updates here that I didn't realize that came along with the 5.1 update, which would be exciting. So if we search for, let's actually go back into NeoVim and search for init command again. Oh yeah, now we're getting more stuff. Look at all this. So there is more in here. more that we should check on. And it looks like I'm also seeing evidence of cache size. So where did that come from? What? No, that's not the only instance of cache size. I found it in other places. Come on now. So they're setting it in tests. Oracle, what is going on? Options. I didn't set this though. Cache. Okay, are there other places where 2000 now appears that are chunk size? No, that would be query stuff. Oh yeah, we still got some mysteries. Maybe though, maybe there's now more clear results on synchronous. Too much data bit there. Let's do synchronous, but let's filter it down to just the DB section. Oh, okay. So still a little mystified of where some of these settings are coming from. I don't know. I'm gonna go conservative here though and set the values that I want. So we've got synchronous normal. And actually, know what we should do? Let's do one more tab open over here. And let's make sure that this thing actually starts up with this init command. Okay. It seemed to. I wonder if it can get, like if the debug toolbar will give us pragmas. So let's look at localhost 8000. Open up over here. Let's check out SQL. No way. There's no way 0 queries are running for this page. That's not true? Surely not. Okay, maybe there were 0 queries. That's bizarre. Well, clearly debug toolbar doesn't tell us this information. That's fine. I didn't really fully expect it to. That's getting there. Okay, so can't do an obvious way to find out. Well, maybe there is. What if we do this? So recall that the manage file, manage.py, has a bunch of commands available to it. One of these commands, you've got your shell command. If we look up here, we've got shell. But there's also db shell. Notice that. And maybe what happens when it goes to the command is it will go through and run the init command stuff, so we'd see the configuration as we expect to see it. So let's do this. Let's change to the busy timeout to be something that we know is kind of a number of our choosing, 9999. That's kind of out there in some sense. Now let's go over here and do uv run manage.py and then say db shell. And at this point, let's try pragma busy timeout. Ah, shoot. Okay. Badi Uzaman. I'm sorry, I probably pronounced that improperly. Thanks for subscribing, even if I butchered your name. Apologies on that part. So I was hoping this would not just try and like launch SQLite with our database, but actually do it with the proper init commands. Or it did, and we're not actually running pragmas the way that we think we are. That's another possibility. I'm hoping that's not the reality, though. Gotta figure out. Okay, let's go back. Come on, Grok. Let's see if you can pull through. How would I check the pragma configuration from Django's DB connection viewpoint? I want to confirm if my init command inputs are having the effect that I desire. All right, cool. So let's follow this route. Seems very reasonable. We don't want to. I mean, I guess we can make a whole management command. I'm not really interested. I just want to get confidence that something that we've set is actually getting set here. So let's go follow this path. In fact, let's copy this code because why not? It seems okay. And we know that we've set that to 9999. We're going to go to uv run manage pi shell. Actually, do I have a make target for that? It's a lot to type. It's annoying. Okay, let's do this. Let's do shell uv run manage.py shell. The future, I don't know that I'll remember this, but I might start remembering it. And then we will paste this stuff. Synchronous setting was 1. There's the cache size set to -2000, but that was like the stuff that was already there. So we want to do cursor execute, where we do pragma with busy timeout. That was the one we want, right? That's the one we know that's going to be our 999 value. So let's do boom, that. And then we say result equal cursor. I could probably just hit up arrow at this point, but oh well, too late. Result fetch 1. And then can I just print the result? Or does it have to 9999? Awesome. Cool. We know it's working. And we know also that it's one of the later ones, right? So these other pragma statements that it's right in the middle. So we know that journal mode's running. We know that this thing's running. Let's set it back to 5,000. I think we're happy. This gives me confidence that the way we're doing this is right so far. And I don't feel the need to verify any more of them. We just need to make sure that we get them right and that the app starts up, right? So something was setting, we saw cache size setting of -2000. And Nikita said, set it to -20,000. Negative numbers means kilobytes. So he's saying, give it 20 megabytes of memory for cache. Let's go read up on that cache size and see what cache are we talking about here. Cache size. So you can give it a page count. And so one way to do this, calculate it, would be like, give it a positive number and its pages. And then there's a particular page size. I want to say it's 1024. Yep. And see that. So that's how much memory you'd go. The other way is like just doing it directly from a size of bytes that you want. Okay, so query or change the maximum number of database disk pages that SQLite will hold in memory at once per open database file. Why do we want this? When you change this, it's only for the session, so you have to set it every time. Default page cache does not implement the full amount of memory as needed. Upper bound. Okay, so the longer this is running, I guess the more cache we can use, which is why they're suggesting it. So, but why do we want this? All right, what is the purpose of the cache size pragma? By setting a larger cache size, you allow SQLite to keep more data in memory, reducing the need to read from disk. Yeah, it's not surprising. Buffer more changes before they're flushed. Okay. What is the default behavior? Translates to 2 megabytes. Okay. Setting it too big can just be extra memory consumption, but I mean, come on, 20 megabytes is tiny. At least with the way that we're using databases right now, it's tiny. I have some future thoughts about other things we might try, whole other projects that could be really interesting. Actually, sure, I'll just share it right now. One thing that's interesting to me is, okay, let's go to Django packages. There is this. Django tenants. And actually, let's take a look at, what is this? Django tenant users. Maybe there's just an interesting thing we can adapt. I'm going to poke at a couple of these for a minute. Some of those are very old, though. So Django tenants is the idea that you can separate users. So like in my app right now, all of the data there's a foreign key to the user. And so every chunk of data is in the same database schema, like table space basically. And if I want to get my data, I have to filter for my ID. If I want to get your data, it'll filter for that ID, so on and so forth. What a project like Django Tenants does, it takes advantage of a feature from Postgres called schemas. Schemas is confusingly named, I think. It just basically means separate table spaces that like you can have the same like actual relational schema, the high level one, but you can kind of separate and have like a different namespace for different users. And the benefit of this is then you can get kind of multi-tenancy where instead of using a foreign key column on a specific model, you can say, if you are in this particular PostgreSQL schema, then you must be for this customer. If you're in this one, you're for this customer. So there's no possibility that if I'm querying for this one, that I'm going to get data for anybody else but that particular user or customer. Hopefully that makes sense. The challenge with this is this is a Postgres specific feature. It's a cool one, but it is not available for SQLite. Let's take a quick peek at these other ones, see what these do or what these work on. Where I was hoping to go maybe is a mode. So remember, everything in SQLite is a file. And you could conceive of a database backend or project where, similar to using PostgreSQL schemas, you could use individual SQLite databases per user or customer, however you want to configure it. And the benefit of that would be very clear. Like if there were any like, I don't know, GDPR kind of things to think about, and you wanted to have great certainty that you had deleted somebody's data and you had it as SQLite files, then you could say, I've deleted your database. No one else has access to it. That file is gone. And you could be confident that it was gone. The other benefit that comes out of this is remember that there's a challenge with write contention. And so as you scale up a system, if you suddenly found yourself in a place where you're very popular, I would wish that on anybody. I would wish that. I don't think I spoke very clearly. Hope you the best success, right? And I would hope if you did it with SQLite, that you'd get a ton of customers. The problem with that, though, is as we just saw, is like writing. Especially if your app is very write heavy, you would start to run into this case where they're all trying to fight for, can I get in and do my write? However, if you were imagine a world where you had a schema approach where it was per customer, I'll use a customer term for a very specific reason. I'll get to that in a second. Then the writing to that particular file is just that particular file. The chance of contention with another customer is very low. The only chance of contention really is if you were making an app where it wasn't just like a per user database. It was more of a per customer or per account. Like you can imagine a team account where you have a bunch of people that all need to use a particular app, and they are all going to be working with the same data because they work together on a team. That is something I've been thinking about. So in that universe, it would be possible to have data per customer be in its own database file. There are complications with that, because think about it, if you wanted to log in, like there has to be some kind of control plane database or some kind of uniform database, at least for like handling auth or something like that, so that Django, if it needs to pick like which database should I use, needs to be able to like find the right one, find out what's the ID for you based on your cookie or whatever, and then route you to the right database. So that is one possibility that I'm thinking of, is like I have not seen anything like that in the Django universe. I think it would be really fascinating. It could be really fun to build. So that's a thought there, and we'll check up more on that later. Nazim, I'm seeing your comment there. Welcome to the stream. Question I have is that am I trying to create a website and convert it into an application? So I already have a website. It is at this site. It's JourneyInbox. It is a journaling service that works via email, actually. So in fact, the ironic part about this particular project is there's not a lot of user interface here. You create an account and you go through an email sign-up flow, and you will daily get a message from JourneyInbox saying like, hey, just respond to this message and we will add to your journal. The hook, the thing that's interesting about this service, and the reason why I've been using it for years, not this particular one, I made this for myself, but I cloned it from another service I was using. I've got 10 years worth of journal history. And every time the prompt email, that's like the daily message that gets sent out, it takes a random entry from the past and drops that into the prompt. So not only are you told like reply to this email to update your journal, but you get that email and in it includes a random previous entry that you get to read and get reminded about what have you built, what have you done in the past, which is pretty powerful, especially kind of as it grows. So that's what the product I'm building. Nirvar, Messi or Ronaldo? I gotta confess, I played soccer in all growing up as a kid, and then through high school, and then I did intramurals in college. But I'm not sorry, you might call it football, excuse me. So here in the States we call it soccer. I hear Messi is amazing. I also know that Ronaldo was amazing. So it'd be hard to compare, but I hear Messi's kind of like otherworldly. I've not watched his footwork enough, but like everything that I hear about him is sort of like legendary. So I'd probably lean towards Messi, but maybe that's a recency bias. They're both great players. Nazim, no problem. Hopefully that response was helpful for you. So we're not going to get to the actual tenancy project today. I think it would be super fun to like figure out how do we set this up and how do we migrate to that. But that's that. And then, oh, Simon, because I think this is Simon. Simon Charette. He's a good developer. Handle multi-tenancy in Django with additional. Okay. But what databases do you work with, Simon? You work with all of them? Okay. Anyway, distraction for today. Sorry, y'all. Let's get back to what we were trying to do today, which is pick the set of SQLite optimizations that we wanted. So we've gone through journal mode, we've gone through busy timeout, we've gone through synchronous, and now we're at cache size. The value we saw was negative 2000, so I am okay bumping it to 20 megabytes. And I think the way the cache stuff gets worked out is there are queries where if you have an inefficient query, then what SQLite will do is at that moment, like so let's say you have a query. Oh, well, I gotta explain a bunch of stuff here. Sorry. If you do not make certain choices in your database, let's say you forget to put a database index on a table. An index is essentially it's a B tree is under the covers of what it's truly called, but it's a tree. So it's like a way to navigate to data and find data through making fewer decisions. Versus if you don't include an index and say you needed to find someone named someone named Z, and it's an alphabetical thing. So on a gigantic table, you could imagine that the way that the table has to process, let's assume worst case that Z is, Z way at the bottom, and it's a bunch of first names or something. I don't know. Is that a first name? I don't know. Whatever. And everybody just happens to be named such that all the A names are early, the B names, and it goes right down the whole alphabet. And so Z is at the very bottom of the table. And let's say that there's 1 million rows in this table. So in an inefficient query, SQLite would have to, in order to find that one row that's at the very bottom, it has to do something called a table scan, where it goes from top to bottom and says, all right, I got to check each one to see, are you Z, are you Z, are you Z? And you can see, like, that's slow. It's in big O notation, that would be O of N. It has to go through N entries. Every single entry has to go through them. So is what SQLite is powerful enough to do is say, wait a minute, I know you're about to make me do a full table scan. And that's really slow. I know that it would be faster if I had a tree, because a tree can be like, just like when you have a dictionary and you're a basic binary search, we can all kind of, I think, conceptually understand this, because I'm guessing whatever language you had some kind of dictionary, a book that has words in your native tongue, right? And so you could start from the middle of if you just take a process where I need to find Z, you can start from the middle of your alphabet in the middle of your dictionary and split it in half, and it's that it's on that side. So you go to the last half of the dictionary and you split it in half, and you split it in half, and you split it in half, and you eventually take through a few steps rather than going through every page of the dictionary trying to find the word. In just a few steps, you get to to the entry you're looking for. And so that's what effectively a binary tree is doing. It's like letting you follow that path that goes down there and makes a few choices. So SQLite's smart and says, what you're about to ask me to do, I see that there's no index on here, which again, tree. When you hear index, think tree. I see that you would want me to do a full table scan, which is super slow. So what because I know it's so slow, what I'm going to do instead is make a tree temporarily and then run the query from that tree. And like it's unbelievable that this is actually fast enough. I don't know how it does this, but that is an optimization that sometimes it makes. In the absence of an index, it will make a temporary table or a temporary index, kind of like to build that out, and then do the query on that. And so I think that's where this cache size comes in, of like allocating space for that temporary table or for that temporary index, is where this stuff would be used. So by giving it more space, let's say you have a bunch of things that are not optimized by accident, and they would be like, we already established this was 2 megabytes, or minus 2000, which we said was 2 megabytes according to the documentation. Then it would, and let's say you had 10 tables worth, they were all not optimized, and these temporary indexes that should be generated would total to 8 megabytes. Well, the cache would have to be flushed if you're causing the queries on multiple of those tables. So if you blow this number up to 20 megabytes, they could all fit in that space, and you could just keep those tables around regardless of the queries that were coming in. Hopefully that made some sense. I think that's why we would want a bigger number. Nazim, I see your questions there. Would it make a hash table then? So would it make a hash table? It kind of gets down to how you're implementing a hash table. I think the answer is probably no. I think B trees are a different structure from hash tables in terms of how they're truly implemented. Although it's been a while since I've made a hash table from scratch. Yeah, the hash table stuff was like, yeah, I think it's be different, because a hash table is like an array, and when then you use the array and you figure out a cache key, or a hash key to find the specific bucket. Sorry, I'm trying to understand your question. Would it make a hash table then? So maybe I'm not following your question totally. So apologies if I'm off from what you're trying to get at there. But if you clarify there, I'm happy to try and take a crack at it. So let's take this though and add this to our list of pragmas. I think we can just take it as is, because it seems like a reasonable number. So we're going to go in here and we're going to add this new pragma. I'm going to keep these all consistently formatted. I think we could do this with the spaces. I'm just going to stay the same way here. So we've got our pragma size, or our cache size of 20 megabytes. We've got foreign keys on from Django, so I'm not going to bother with that. Oh, you know what? This is all that stuff I was just saying might actually be about this temporary tables thing. So I could be off on here. Let's take a look. So we've already explored cache size. Let's look at temp store, what that is. See if I'm on target or not. So let's look at temp store. And let's actually check what our temp store value is over here, so we know what we're working from. Temp store 0. Temp store 0 is the default. So temp store, you're just going to use the file. So query or change the setting of temp store parameter. Is used to determine where temporary file tables and indices are stored. Okay, so maybe what I was saying earlier about it's going to create a temporary index for you, it's where it's going to write that. So it might be able to just write it directly into memory instead of on a file. And by keeping it just in memory, and probably it might be a combination of keeping it in memory and then having a big cache, would allow this to be faster. So this is really trying to save you. And there are things in SQLite that can tell you, hey, what you're doing here is not great. You need to add an index on here. But in the absence of that, SQLite's trying to help you make decently performing queries by doing some work on your behalf. So I think what we want to do is just take this one and use temp store. We can use memory, which should set it. So let's actually go and just play with it over here. Pragma, temp store. Whoops, not pragmas. Temp store equal memory, and then that should be a value of 2. Yep. Okay. So we'll come back to our code, and we will take this, and we'll do temp store, and we'll change the semicolon and say memory. Okay. What's left? I think we've got about, that might be it in terms of pragmas. Speeds up performance a lot. I'm interested to see how that will work. Do not use cache equals shared. Okay. You don't have to convince me twice. We've already got, this is a subtle one. This is actually one that was only really available from Django 5.1. And we're taking advantage of it here, transaction mode immediate. I did look up the rationale for why you want to do this. And it had something to do with when you get these SQLite busy errors. If you don't do immediate, then I think what can happen is, I'm afraid I'm going to butcher it if I describe it wrong. So by saying begin immediate, you're sort of saying to SQLite, I want to start a transaction right now, not later, not whenever I need it. Because there are some things along the process of doing operations in SQLite that don't necessarily need a transaction right away. And then you might find a point, or your connection might encounter something where like, oh shoot, I needed to do a transaction here, and I got a bunch of the other pending changes. Like it gets a little complicated. But this was a good one. But the way this manifested in Django was to set this transaction mode, which was a new feature in Django 5.1. And just by setting it to immediate, it gets this behavior that's described here in this post from Nikita. So that's done. We're not going to open up 2 connection pools. Just some of this starts getting down to like very lower level specifics, and then Nikita includes a bunch of code for Go. Clearly, we're not using Go, so that's where I think we run out of gas with this post. But nonetheless, this is useful. I just realized, gosh, we spent like over an hour talking about SQLite pragmas. Hopefully, it was interesting to me to get into some of this stuff. But the change set is looking pretty light. So really, we've got 2 files, and one file is just because I added a new convenience shortcut. We did confirm through getting the connection on the Django shell. Where did that go? Here, that we saw our value. This is actually good to know that you can go into the connections, you can get out the default connection, and then you can start from that. You get a cursor, and it can actually execute raw code, raw SQL in this case, or raw instructions to SQLite. And then you can, from the cursor, you execute it, and then you fetch the results back, and you start to inspect that. So that was actually kind of a cool way, something cool to see in the process. All right, so let's make sure that this is still running. And unfortunately, I don't have a good set of data that I can really check this with. This is something I'd have to validate. Like I have some customers that have some queries on my SchoolDesk app that there are some slow queries. I'm super interested to apply all these optimizations to SchoolDesk and see what kind of benefit we get out of there. But really at this moment, I just want to make sure that the app loads okay. And it's really challenging to tell, oops, that's the actual JourneyInbox. That was pretty quick, but not what we're trying to test. So let's look at localhost 8000, also very speedy. And I don't know what we can see out of this. Yeah, I'm surprised there are like literally no queries on this page. That's bonkers. Very static page, I guess. So let's log in here. This should be using a test database. And I always forget. Matt at testing, create horse. So Matt at testing, oops, testing.com, create horse. Okay. Dang, that seemed really fast, but again, this could have been super fast before, and I just didn't even know. Don't know. It's hard to tell. But the fact that I don't know, that is. I don't know. That'd be amazing if all this stuff just got insanely fast because of some basic optimizations. And the sad part is like, there's part of me that like wants to know what are the biggest optimizations, what move the needle the most, and applying these all at once, as I wouldn't know. I'm not worried that any of them are going to cause negative effects. The people that this is not the only person, this Nikita person is not the only person that I've seen talk about these particular pragmas. These seem to be like kind of a well-known set. There's another one, just started following him recently from the Ruby on Rails community, Steven. Yeah, here he is. This gentleman here, Steven Margheim. Sorry, Steven, if that's not how you pronounce your last name. And he's been doing a lot of stuff to make Rails super fast with SQLite. His whole philosophy, I listened to a podcast with him, actually, getting back to that whole high-performance SQLite. If you want to get a flavor of what kind of person Aaron Francis is like, there is on YouTube, YouTube, come on now, YouTube. Aaron has a channel. And here's his channel. And in fact, oh look, this was a very recent interview. I mean, I guess it was 4 months ago now, but he did this interview with Steven, this guy that I started following, talking about how Rails has really upped their game with using SQLite. So there's a bunch of interesting stuff out of there. So if you want to, just trying to give you like a couple indicators that there are some smart people who've spent a lot of time studying this stuff. According to Steven, there might be some things that we would need to do in Python or Django, maybe even to get more speed out of it. He did some really low-level stuff, but I don't know how much is specific to restrictions that Ruby had in place on how its C API worked with SQLite. But nonetheless, he's an interesting guy to follow if you're into tech stuff on X. Okay, so where does that leave us? That leaves us with this, like, we've tested that it worked. I think I'm happy with it. I think what I want to do is this. Let's commit it. We'll say add SQLite DB pragma optimizations. And this fixes number, what is it? 244. All right. Then I'm going to do something that hopefully will not, actually, let me run the test, make sure the test didn't break. Cool. Tests are good too. I'm going to do something that messed up the stream last time, but I think I have a fix. Last time I did the stream, I actually had to break it up into like 3 streams because my internet was garbage. And part of that was it was pulling down a bunch of data from different registries and Heroku and a bunch of different places like that. But in the intervening time, I said, I'm going to buy a repeater. finally bought a repeater, and according to speed test, I've got actually way better connection down here now, because I'm connected to a repeater in my house. It cost me $25. I should have done it a long time ago. So what I'm gonna try is do a deploy, and with any luck, it goes fast. I think this is gonna, when I'm using Kamal, Kamal deploy is gonna prompt me to do type in my 1Password. I don't even want to show how many characters I have in my master passwords. I'm gonna set it on secrets mode real quick, and then we'll just get the deploy going. So let me hit enter here, and there it's prompting me for the password. So I'm gonna punch over here, and then I'm gonna type in my password over here, blah, blah, blah. And so now that's done, and I'm waiting for it to react. There it goes. Okay, bring this back. So it's going through, it's building the image. I think there should be a lot less to pull because a lot of this stuff is already cached. But even if it wasn't, I think my connection's better now. So this will get those database optimizations out there. And while that's going, actually, let's do the same thing, school desk, because that seems like a good idea. So let's go over to the homeschool repo. Let's fetch those changes. Let's open up project settings. We're going to go to init command. You got same stuff we saw on the other one. Literally just gonna steal all this. I've already talked through it. Don't need to talk through it a second time. We will put that here, like so, and get rid of this. Okay. And then we'll commit. While that deploy is going, we're knocking out 2 birds with 1 stone. Okay, and then we'll say add SQLite pragma db pragma optimizations. Push that up. Neat. Okay, so this is going to run. We are currently, so we've already built our image. It is deployed. We're out there swapping images with our machine on DigitalOcean. So actually, I think this might be our second deploy in this box. It's the first time. I think I described last time when you do the deploy, there's a load balancer in place and it points at an application. So it's directing traffic to one spot. And what happens when you start up a new deploy is the new web app spins up, and eventually in this deploy process, the load balancer points at it and says, "Are you ready? Are you ready?" And then it starts to drain traffic from here and redirect requests over here. And once all of the traffic is requested, is moved to the new application server, then the old one can finally turn off safely. And I think that might be the first time that we actually went through that process with this deploy. So let's check and just make sure that JourneyInbox is still up and online. It is. Cool. And maybe it's faster than ever. Okay. What to do next is the question. I think I did not realize it was going to take an hour and a half to go through Pragma configuration stuff. So I'm going to probably talk about what's going to happen next time, and then we'll just meet again next week on the 2nd. Like I don't think anything's going on. So there are things I would like to do to this app. There's a bunch of features still that need to be built, but I still want to make it even easier to get going with the app. The application, the process right now is you sign up, you go to this page, you put in an email and a password, and you get an email sent to you. If you're joining right now, you're free to give it a try for a couple weeks and see how it goes. Then you go, and part of it, I wanted to avoid spam. So what I did is I sent, like, as a part of this process, you had to verify your email, because there's actually twofold factors that, like, I want to keep out spammers from signing up for the service. Also, since the whole service works via email, I need to verify that you actually own that domain, because it's vitally important that this particular product be able to have a very high sender rating. And if I'm sending junk mail to mailboxes that don't exist, then my sender rating goes down and the whole service could implode. Like, that would be bad. So it was critically important that I have that verification step. But I was thinking more about this, and I think there's really, in my mind, no reason to have a password. Like, most of the time you're going to be interacting with your email anyway. So what I'm going to do is switch this to a setup that you may have encountered, which is less common, but still exists out there, where you can drop in your email address, and then you don't even have to put in a password. It just sends you like a sign-in link to your email. The very security conscious might be like, "Oh, Matt, what are you doing?" But I've been convinced by, I'm on a blank on his name at the moment, but there was someone on X that made a pretty compelling case for it. Basically said, like, if somebody has access to your email already and is able to get in there and log in through your login link, you're already toast. Like, that is, email in this day and age is like keys to the kingdom. So they can access like all sorts of stuff if they're in there. So my viewpoint is like, that's reasonable enough. I don't expect people would be signing up in libraries or stuff like that. So we would make this process such that you can sign up just by providing an email. You get the verification link that does two things. It verifies who you are, but it also goes ahead and logs you in. And when you come back to the link and follow it, you will be logged in, and I will set a cookie in the application such that you'll be logged in for like a year. So there's a default session window for how long a session is considered valid in Django. And again, this person is, it's the guy behind Levels.io. So he has, I think that's his handle in X too. Levels. Yeah, this person. What is his name? Okay, I don't want to see. Take me to his account, please. Oh, well, whatever. His name is Peter. Peter, there it is. Anyway, Peter makes a case of like, just let people log in and let them stay in, and it's okay. So I'm going to follow that advice. Excuse me. Frog in my throat. Sorry about that. And we will make sign up as brutally simple as possible. And then login will be, hopefully you'll never have to log in, or you'll log in once a year, once every 2 years. More often than you'd probably getting a new device more often than you'd have to log in. And so you just have access to your stuff on your account. So that's the plan. I think that's the issue that I want to do next. What's going to be interesting about it though is that currently we're using Django all auth, and it does a bunch of stuff for us. And maybe I want to ditch it. Like, I'm a big fan of Django all auth for what it does, but I want to explore either, do you have options that allow me to do what I want to do? And if not, I'm not afraid to say like, well, okay, maybe you're not the right fit for this project. So that's the thing that I want to look into next. There's going to be implications of, if we're doing the sign up for them, what does that mean in terms of keeping their information? Like, how does that work for login? What kinds of temporary hashes are we going to store? Yada, yada, yada. There's a lot of things to consider there, and how to integrate that smoothly. But that actually is like the fun of this kind of next project. So I don't actually know deeply what I'm doing here. I have an idea in my head, and we're just going to go after it. So that exploration should be part of the process, which should be entertaining. So we didn't get to new feature work. Oops, my little to-dos still behind my head. We didn't get to new feature work tonight. We just got to the SQL optimized stuff. Hopefully you learned something along the way though. If you do me a favor and leave a thumbs up on the video or subscribe, whatever. There are also other ways you can support me if you want. There's my website, mattlehman.com, where you can read my book. You can read it for free. You can buy a copy if you like an actual print version. But I walk you through how to use Django, a lot of the framework, major elements of it. so you can really get an understanding there. You can also join as a YouTube member. Well, I don't know what the term is. If you would like to support me financially, of course, no obligation to do that. I'm happy to do this stuff, and I also have a day job. So thank you for joining in, and I will see you next time. Take care.